Welcome. Thank you very much for coming. My name is Luca Bandini. I am a sales consultant for Tableau, mainly based in our London office. And today I come here from my native Italy to be your very own guide in the wonderful world of level of detail expressions. People in our line of work, people like us, are known for their ability to harness the power of data and generate insights that drive decision-making in any industry at any level. Can we turn the volume up for a little bit? People are here. Thanks. We're also sometimes known for our questionable ideas around what we consider cool and fun. I, for example, in my free time, of course, enjoy hacking my favorite data visualization product to draw pictures of myself using polygons. Oh, my lord. You're laughing at me now, but you're not that different because out of all the things you could possibly do in today, it's the last day of conference, it's the day after the party, the big party that we had yesterday. You've decided to attend a session that has a horrible pun in the title and that is about some of the most complicated stuff that you can do with the product. So give yourself a round of applause. All right, on a slightly more serious note, who here has used LOD expressions before? Seen a lot of hands, a lot of beautiful people. That's very good. If you don't see yourself necessarily as an expert on LOD, I just want to give you a fair warning that this is not the session where we look at the basics of LOD expressions. This is where we really understand some of the key mechanisms behind LOD expressions that really allow us to unlock some advanced analytics use cases. That said, if you're not an expert in LOD yet, I don't want you to run away and feel like this is not the room for you. The session is being recorded. I don't want you to follow every single step. I don't want you to follow on every single detail of the calculations. Just try to follow on the concepts behind the calculations that we're writing and try to focus on the teachings and the things that you can unlock with that little piece of knowledge that we're going to focus on today. So let's take a look at what you can expect from the session today. If you've used Tableau for a while, you've probably realized by now that out of all the things that you can do with the product, 95% are either very, very easy to do or very, very easy to Google or ask someone for help. You've seen the community here at conference is pretty amazing. So there's a lot of resources out there if you're after some answers to your questions. The remaining 5%, though, of the things that you try to do with the product can make you go crazy. I see some nodding. Can make you go crazy trying to find that answer. Maybe because you don't know the terminology, you don't know how to ask that question. So you can very easily get stuck on those advanced analytics use cases. So my goal for today is for you to leave this room needing to Google a little bit less and maybe being also able to contribute to the community yourself about these more advanced analytical topics. All right, so I mentioned that this session is not an intro to LOD session. But what I want to do is, I feel nice, so I want to give you a little bit of a warm-up example. So we're going to start with one of my favorite examples to explain the value of LOD as a technology, as a technique, as a type of calculation. This is actually one of my favorite examples because it is one of the analytical use cases that drove the creation of LOD expressions. Meaning, when our engineers, when our dev team were thinking about implementing this feature, they had this use case in mind, among others. So what we're looking at here is a very simple visualization, a bar chart with a bunch of colors. And the goal of this visualization is to show us whether we are giving too high a discount to customers in industry, a specific industry. It's very easy to see for this one, for example, that our customers in the agriculture industry are receiving a very high discount, a discount that we consider to be too high. We have set our threshold at 6%. The discount that we calculate here is free units given over total units bought. So 6% is what we consider to be the maximum acceptable limit. And agriculture, as a sector, has exceeded that limit, which I can very, very easily see from this dashboard alone. The key that makes this dashboard unique and that adds a lot of value to it, in my opinion, is this little friend right here. This tells me that even though transportation, for example, overall is doing fine, we're not giving too many free units to our customers in transportation, there are 3 customers within that industry that have been given too many free units, which is a piece of insight that I could never get just by looking at a standard bar chart aggregated at the level of industry. So what this gives me is that piece of insight at my fingertips as soon as I open this dashboard, and it allows me to then go and see, okay, who are these customers? Then I can click, and I can go to a new visualization, the level of detail of which is the level of detail that I want, customer, and see who those customers are. By the way, this is fake data. Do not go and harass our customers from GM or any of these companies because we are not giving them free Tableau. Right, so this is a typical example of when LOD, the core meaning of LOD, becomes useful. We are capable of aggregating data at a deeper level or a different level to the one that we have in our main view. Going back again, this is our default view. Level of detail of this visualization is industry. We want to aggregate a metric at the level of the customers within that industry, and that's where LODs come in and help us. Today we're going to focus on something else, how to take LODs beyond their initial intended use, and how to unlock some advanced analytical use cases with that. Let's start with one of those sort of buzzwords that you hear a lot, one of those keywords that I mentioned earlier. If you don't know this word, like I didn't know this word, this terminology 4 years ago when I joined Tableau. And now that I know it, I see it everywhere. But before that, it was very hard for me to wrap my head around what this meant. Proportional brushing. Has anybody used it? Who knows what it is? See? Not many, I see 2 hands. Cool. The proportional brushing is a technique that allows us to compare a subset of our data to the total data that we have. Let's take a look at this visualization here. We have, again, a very simple dashboard. We have 2 charts. We have our sales by over time, so from early 2011 to late 2015. We also have a map that we can control with a filter that shows us the breakdown of our sales for countries in a specific market that we have selected. So if I pick European Union, I now have the breakdown of sales over time in the European Union and for the specific countries that we have in the European Union. What I can do with this that makes this dashboard really powerful is I can click on a country, Italy. Take a look at that black line. Let me do that again. The black line that I have there is not changing. It's ignoring the filter. But I do have another line, the blue one, that has picked up on that filter and is showing me sales over time for the country that I've selected, Italy. So now I'm seeing the contribution over time of the Italian market to the global market, to the global to the EU market. And then, by having those 2 metrics at the same time on the screen, I can also calculate things like a percentage. So down here, I have the percentage contribution, month over month, month by month. What is the percentage contribution of Italy to the European market? So how do you do something like that? Let's move to a how-to. But before we do that, there's one slide that I want to show you today. There's one little piece of knowledge that I want you to walk away with today. And it's the order of operations in Tableau. I promise you this is the only slide that you will see from me today. Things in Tableau don't happen randomly. Everything that you do in Tableau generates a query, generates an action, generates something behind the scenes. All of those things that happens behind the scenes happen in a certain specific predetermined order. Data source and context filters happen first. Remember that. Fixed expression are evaluated right after those filters. Only after that do we evaluate dimension filters that you apply, and then include, exclude LODs, and other things down the line, like table calculations, are the very last thing that we evaluate and compute in Tableau. So let's see how we can use that little piece of knowledge to unlock an advanced analytics use case. Proportional brushing. So what I need is a calculation that will return sales over time for a market and not be filtered by a filter. So what I'm going to do is create a new calculated field. And just make it larger for the people in the back so everybody can see. What I need is to fix at the level of my month of order date the sum of sales. Let's call this fixed sales. Now, what is this calculation giving me analytically that is different from what I already have in the view? What I have in the view is sales by month of order date. How is this different? It's not different at all. So when I click OK, drag my fixed sales to my rows, you can see that these two line charts look exactly the same. There is no analytical difference. I have fixed manually the level of detail of that calculation to be month of order date. But that happens to be the exact same level of detail that my visualization is already at. So analytically, this calculation makes no sense. It isn't adding anything. But if you remember that little piece of knowledge that I tried to impart on you with that slide, this is a fixed calculation, and it happens at a certain level in the pipeline of execution of our calculations. So when I apply this filter and select European Union, you can start seeing the magic. The one on top is a regular metric, a regular expression in Tableau, sum of sales. It is affected by design by all dimension filters. I'm applying a filter, and for the European Union, I'm seeing the data for the European Union. The one below, even though analytically it doesn't really make a lot of sense, it's not adding anything, has the ability to ignore those filters. And this unlocks that capability to compare a subset to the rest. Now, have I achieved what I wanted to achieve with my original dashboard? No. Why? Exactly. So what I have achieved now is I can see the contribution of a market as compared to the global sales that I have. But that's not what I wanted. I wanted to look at the contribution of a country within that specific market. So I do need that filter to be applied to both calculations, even the LOD one. So how do I do that? Remember? Yes, I heard that from over there. Context. If I make this filter a context filter, then I'm promoting that filter in the pipeline of execution. It will happen before fixed expressions, and it will be applied to both. Let's take a look at how that works. Add to context. And now I have a filter and two metrics that are responsive to that filter. But this other one filter, the one on country, is not a context filter. It's a normal filter. So it will only be applied to the regular calculation that I have, not to the LOD one, not to the fixed expression. So now when I go and select Italy, boom, the one on top, the normal calculation, is filtered by my filter, as by design. The one below is not. And then it's trivial to use this to calculate a percentage, one divided by the other, very easy. And I can go and create a user experience that looks like this, where I'm given a very, very simple dashboard that can be used to do very, very powerful advanced analytics. Making sense so far? Cool. All right, I want to show you another example, very similar to this one. And again, terminology that is crucial to know when you're in the Tableau world, and that can make you go crazy if you don't know what you're looking for, and when you're trying to ask that question to someone in the community or on Google. It's an example on what we call market basket analysis. So what is market basket analysis? In this example, we have sales for a hypothetical company. This company specializes in a bunch of different industries. We sell products in different categories of products. So what I want to know as a marketer is when people buy something in one of our categories of products, what else are they likely to buy? So this dashboard gives me the ability to click on paper, for example, and see that when people buy paper, 11% of the times, they're also buying binder and binder accessories. 12% of the time, they're buying telephones and communications products. And this is very, very crucial, very important information if I'm trying to understand my customers' behavior and how to influence them in the future. So how do I do something like that? Well, first of all, I need to be able to pass the right filter, to pass on the right information. I need to make my action influence the chart just right. So what I need is to be able to pass the order ID, which I'm going to bring to the detail. Now, all of these bars will be broken down to show the different orders that are within them. That gives me the ability to go and create what we call a worksheet action. It's going to be a filter action happening on the market basket how-to sheet. It's going to happen on select, and this is key. It's going to happen on a selected field. It's only going to pass the order ID, not the subcategory, not the category of product. So when I select that field, order ID, if I've done it correctly, hit OK, I should have the first step of my calculation. I'm passing that information to my sheet that I want to filter the orders that contain paper, the orders that contain binders. Okay? What I'm missing is the second element, where I have another calculation that is not filtered by this one, by this action filter that I've created. And any guess? What should we use for that? Yes, a fixed LOD. So we're going to do exactly the same thing that we did earlier. We're going to create a fixed LOD calculation that will fix the level of detail to the product subcategory level, and is going to aggregate a sum of the number of items. Let's call it my fixed sales. Now, again, analytically, this is not different from what I already had. I'm fixing something. I'm manually forcing Tableau to fix the level of detail of something to the exact same level of detail that I already have in the view. So when I bring that in, not exactly revolutionary. It's showing me exactly the same stuff. I don't need the order ID on this one. Let's remove it. So it's showing me exactly the same metric, except this one couldn't care less about that filter. So when I apply that, it stays exactly the same, giving me the ability to do that percentage calculation that really tells me, okay, when people buy labels, they also buy envelopes, which I probably should already know, but you know, it's very, very key information if you're trying to understand your customer's behavior. All right, so before we kick things up a notch, because these were kind of easy examples on how to use this concept of moving, of playing around with the order of operations to our own advantage, we have a new feature that is coming in the next release of Tableau that is going to make these last two examples that I showed you a little bit easier to achieve, and that combined with the techniques that I'm showing you today will be amazingly powerful. I would call this new feature that we're bringing in, set actions, the biggest breakthrough since the introduction of LOD. So I really recommend that you go and check these sessions. They will be available on demand, and combined with the techniques that I'm teaching you today, I think that they're going to be really, really useful. So the next example that I want to talk about is slightly different in that everything that we've seen so far, oops, let's go to this one. Everything that we've seen so far played around with the idea of giving very, very advanced insights through a very, very simple visualization. We had one map and one line chart. We had a bar chart with a bunch of dots. Very, very simple visualizations. This one is an example on how to use that technique that we've learned to make a visualization look nice. So it's a slightly different take on the same technique, a slightly different take on the same concept with very, very different results. So what we're looking at here now is a dashboard where we have a map of our profit by country, and we have a line chart that allows us to compare one country with another. It's a very good, you know, analytical use case. I might want to compare sales for, let's say, Italy and Spain. And after I've filtered, it's a very reasonable visualization. If you remove the filter, you end up with that horrible spaghetti mess that, you know, doesn't follow any best practice whatsoever. Have you been to any sessions around best practices? This is the first thing that they will tell you to remove. Too much color, too many items, too many, it's impossible to read. So this one only makes sense after you've performed the filter. So wouldn't it be better if we could create the viz like this? When we open the viz, we see one single beautiful line chart with one single metric, which is the overall sales, profit over time. But when I select a reasonable amount of countries, Portugal, Spain, the UK, Italy, then that visualization starts breaking down that line, and I'm seeing a very useful chart, but without showing people something that makes no sense when they open the visualization, which makes it very, very clean, very easy, very user-friendly, which is very important for adoption. So how do we do something like that? Let's move to our how-to. So what we have here is our standard line chart. Now, what is rather peculiar about this visualization is that we need one piece of knowledge, one element of knowledge around what the user has done, an action that the user has performed. What is that action? What do I need to know? Filter, yes. I need to know if they have performed the filter. If they have performed the filter, then I want to break this down, put the color on my line chart. If they haven't performed any filter, it makes no sense to break that one line down. So the key element to know whether they have performed the filter or not is to count the number of countries that are actively selected in that map. So how do I count things in Tableau? Is there a calculation for that? Count distinct, yes sir. So when I do a count distinct here, count distinct of countries, it doesn't work. It's breaking down that calculation by the level of detail of the view, which by default is the month. So what I need to do is to wrap that calculation around magical curly brackets, make it a fixed calculation, and make it flat. So now what I have is the total number of countries that exist in my data set, 147 countries. When I perform a selection here, remove some of these countries, absolutely nothing happens to my calculation. Why is that? Order of operations, it's fixed. It's a fixed calculation. It ignores dimension filters. So how do I fix that? Context. Yes, when I add this to context, this action, by the way, action filters are exactly the same as dimension filters computationally. So when I apply that and add that to context, the number goes down. 1, 2, 3, 4 countries selected. And then I can use that little number to make my visualization behave as I want it to behave. So what I can do now is this. Actually, I already have it here. If the count distinct of my country, fixed with the curly brackets, is smaller than a certain threshold that I have deemed to be reasonable to show that, that the line chart broken down by country, then give me the country. Otherwise, give me nothing. Give me Luca. Give me, it doesn't matter. Don't break it down by any dimension, right? So when I hit OK, bring that dimension to color rather than the normal country. This one I don't need anymore. Let's bring it to the actual profit. Now it's breaking it down. The threshold that I've deemed reasonable is 20. I actually think that's way too much. Let's make it 4 as the threshold. That is less than equal. Yes, I've selected 4. The threshold is 4. It's reasonable to break it down. As soon as I add another one, Argentina, it's not reasonable to break it down anymore. We've selected too many, right? So now it's time to bring it back to a visualization that can actually be consumed. And I could do fancier things like put in a warning, again, based on the number of countries that have been selected, display a warning that says, too many countries selected, please select up to 5 countries to break this down in the line chart. So, again, same piece of knowledge, playing around with the order of operations, knowing what happens when we fix something, knowing what happens when we add a filter to context, allows us to unlock this little cosmetic trick for our visualization. The next one is everybody's advanced visualization on a map, a path analysis. Everybody loves a map. Everybody goes crazy for a path on a map. This is one of the most popular visualizations. Every time you show this, people are like, oh, that's funny. Oh, what's that? That's interesting. In this case, we're looking at donations. We're looking at donations going from one country to another. We have a parameter that allows us to select the country, and then we see the flow of donations going from that country. In this case, we've selected the United States. I can change that to the United Kingdom, which is where I live, and we can see the amount of money that people are donating, where this money is going, in a very effective visualization that really tells us a lot about our data in a very, very effective manner. So let's take a look at how this is done. When we open our map and create the visualization with our path, with our lines, with our donor country and recipient country, it looks like this, which is, again, a horrible spaghetti mess that makes no sense, right? It's impossible for anybody to take advantage of this visualization to get any insights at all, because there's way too much information. So the first thing that we need to do is filter it down. Remove some of those elements, remove some of those lines, so that a human brain can actually make sense of what is going on with the view. So naturally, the first thing that I will do is take my country from the dimensions, put it on filters, and select United States. And surprise, surprise, Tableau is pretty diligent in doing what it's asked to do, and it will do that, and it will show me the United States. Again, I've gone from a very, very useful visualization because it had way too much data to a very, very useful visualization that has one dot. It's a fantastic job, well done. So what is the problem here? If I filter down to a single country, I am losing the recipient country. So that doesn't work. So how do I fix that? Completely unreasonable question on my part if I don't show you the data structure first. So let's do that. Let's remove this filter that makes no sense. And let's go to an explanation of how this data is structured, which is key to understanding how to build a map like that and how to filter it correctly. Whenever you want to make a path analysis on a map in Tableau, you need data to be structured like this. You need from and to, donor and recipient, right? And you need something to identify uniquely that transaction. In this case, we call it edge. We could call it transaction ID. And then we have a path. Again, a numerical way to tell Tableau how to draw that line. Where does it start from? Where does it go? Okay? So how can we use this to change the way the filter behaves? Let's take a look. Let's create a calculated field. First, I want to select the countries that my end user has picked in the parameter. So very easy. If my country is the same as the one that has been selected with the parameter, then 1, else 0, end. Very, very basic calculation. Let's call it our selected country. Hit OK. Let's pause things for a second because I need it to be discrete. Let's bring it here, make it discrete, and play again. Make it a bit larger so you can read. Now, I've selected the United Kingdom, which is not the best for this example. Let's move back to the States. And now, what I have, very simple, I have a number 1 wherever the United States are selected. Okay? So whenever I have that, I'm applying a 1 to that line. Now, how can I propagate this 1 so that it's available for us to use as a filter even for the other country, in this case Afghanistan, in this case I think this is Gaza, yes. Any ideas? It's a fixed LOD, again. So what we need to do is take this number and aggregate it, but fixing the level of detail to another element in the view. So fixed, make it bigger, at the level of my edge. So for every edge, pick the max of my selected country. close the parenthesis, and call it filter. Now when I bring that in, let's make it discrete. Make it larger so you can read. And now, look at that. I have that little number 1 right next to both countries within the same edge if one of the two edges is the United States, which is the country that I have selected within my parameter. To make it a little bit easier to see, if I bring this to color, now wherever the states appear, the entire edge is selected. If it doesn't appear, it's not selected because the max of that calculation will always be 1. So if I go back to my mess of a map and use that filter here as a filter now I've achieved exactly what I wanted to achieve, which is keeping both ends of the edge, because I'm not using a simple filter. I'm using a filter powered by advanced LODs calculations that keeps both edges, that aggregates that calculation that I made to pick the right country at the level of the edge rather than the country itself. Making sense? Cool, I see nodding. All right, this was another example of how to, I think it's a bit of both actually, to do cosmetics, to build a chart that looks very nice, but also how to use analytics to make a chart relevant, because the first example that we had was not relevant at all, because it contained way too many lines, way too much information to be used by anybody. All right, so for our next example, we go back in the realm of advanced analytics that really enables fantastic insights for the organization. And I like this one because it's sort of an expansion of the example that we looked at. The idea is that we need to propagate our information, that we need to use LOD to make data appear where it wasn't. So let's take a look at this example. It's centered on competitor benchmarking. Here we have a company, our company, that is doing very, very well on the market. If you look at the scatter plot, we are doing amazingly well in terms of just sheer size, sheer volume of sales. We are an absolute market leader in whatever it is that we do. We're also doing very well, although we're not that massive, in terms of growth. So we have some small players that are growing 65% annually. We're not growing quite that much. We're growing 8.2% annually, but still, we're doing pretty well. We're doing better than the industry leaders. But if you look at this chart, you can see that the area that we're growing the most in is clothes, shoes, and jewelry, 8.8%. It seems to be a big trend in the market. But then, if I click on Income Corporation, our largest competitor, that chart shows me the difference in growth between us and them. So it shows me that we've grown 46.5% less than our closest competitors have grown in the past year. So it means they're catching up. They're catching up in the industry that we're invested in the most. We're growing a lot. That is the industry that we're growing in the most. But still, our closest competitor is catching up. That's not very good. So this is a fundamental piece of information that we need to have about how to run our business next year, where to invest our money, how to strategize around growth. We thought we were doing very well. Turns out we're not. So how do you do something like that? Again, the crucial part about this is knowing the structure of the data. So let's take a look at how the information behind that chart is structured. So here we have a data set. Maybe we've acquired this from an analyst, a market analyst, that contains the growth last year for all of the companies in the space, including us. So it's one single data set where we have everybody listed as a company, including our company. Okay? Now, if you've used Tableau before to compare things, which you probably have, you realize that it's very easy to compare A and B when A and B are two metrics, two dimensions. If A and B happen to be two rows in your data set, and you want to compare exactly A and B, it can become a little bit more difficult. And you end up using crazy joining tricks, custom scripts, custom SQL, sometimes some crazy blending that makes your performance, that kills your performance and makes it terrible. So this example shows you how you can do that very, very efficiently with LOD. So let's take a look at the first calculation. Actually, I don't need to show you that one. It's so easy. The first step of this technique is to filter. We need to pick our company. We need a metric that gives us our company versus everybody else. Okay, done. So what happens here is we have 29%. Let's take a look at, again, clothes, shoes, and jewelry. Growing 29%, whereas here, this little data point is blank. It's null, because we have filtered out the data for anything other than our company. Now we need to use a trick that is very similar to the one that we used before to propagate this value, 29%, so that it's available there as well, so that we can use that to compare our growth to someone else's growth. So how do we do that? Another beautiful fixed calculation. We're going to fix at the level of product category. Again, the max of our year-over-year growth. Now, let's call it our propagated value. If you take the max between a number and null, what will Tableau return? That number, right? If I take a max between 29 and null, it will become 29. I'm fixing that at the level of product category, so that happens for every single product category listed here. So when I bring that propagated value here, boom. It's not formatted very nicely, but it's there, right? I have that value exactly where I need it. My growth has moved from here, where it's really hard for me to compare that 29% with everybody else's growth, to here, where it's trivial to compare that to another company's. Because all I need to do now is take this value and subtract, this value. Let's do it in a bigger calc. We're not in a rush. Let's create a calculated field. This one minus this one. Bring that in. And now we have that difference propagated and calculated. And it's very easy to do difference. It's very easy to do to divide one by another. As long as we have that in a calculated field and we have that side by side with our other metric, it's very easy to do that. And the rest is, frankly, a little bit of cosmetics, where all I need to do is visualize that in a scatter plot, break it down in a bar chart, and I can use that piece of knowledge to compare my performance to everybody else's in the market. All right. So for our next example, I again want to show you how to use an LOD trick to change the way that Tableau behaves by default. There are certain things that are very, very much ingrained in Tableau's behavior. Let's think back to our example where we talked about the filtering on the map. I bring a filter, I filter country. Tableau doesn't care that I mean keep that country's donations. It filters down to that single country, right? In this case, we're looking at retention analysis. The goal of this dashboard is to show me whether people keep buying quarter after quarter. So I want to have this list shrink as I select more quarters, because less customers will have bought in 5 consecutive quarters than customers will have bought in 4 consecutive quarters, right? But by default, here we have the default behavior. Filters in Tableau are essentially and filters. They're not or filters. What will happen is when I select another quarter, Tableau will add all of the customers that have made purchases in that quarter, which is the exact opposite of what I need for retention analysis, which is what we're doing here. So I need to use a technique to change the default behavior of the product. All right, so let's move to an how-to. So what is the key piece of information that we need to unlock that? And it's very similar to something that we've done before, except we did it with countries. Now we're doing it with time. We're doing it with quarters. We need to know how many quarters the user has selected to be able to check what is going on. So what I need is, again, a fixed count distinct of my order date quarters this time. Let's call it count of quarters. Hit OK. Becomes a measure available here. When I bring that in, 16. Is that the number of quarters that the user has selected? No, it is not. Why? Yes, I love you guys. You are following me. Context. We haven't added that filter to context. So my fixed calculation ignores the fact that a filter has been performed at all. So what I need to do is take this filter over here and add it to context. And now this is telling me 4 quarters in total have been selected. So now I know what the user wants to analyze. They want me to filter down to the customers that have made purchases in those 4 selected quarters. So what's the next thing that I need to do is that. I need to know within those 4 quarters that have been selected, what are the customers that have purchased in each and every single one of them. Another very simple LOD calculation. Let's make it bigger. Now I need a count distinct of, again, the order date quarters, but I need this one to be fixed at the level of customer name, because I need to know that for each and every single customer. Let's call it number of quarters for customers. When I bring that in, I've already applied my filter to context. I've already added that to context. It's already having an impact on this fixed calculation. And there I can see that there are some of these customers that have purchased in 4 quarters out of the 4 quarters that I have selected. Let's make it a little bit more clear. Create another calculated field. Let's call it our, again, filter. The number of quarters for customers needs to be the same as the number of quarters, total, this one. And let's aggregate this one as well. Let's just grab it from here, put it there. So we get rid of that error. Hit OK. Let's bring that to my color. And now I can see that in my bar chart, there are some customers, Shaheed, Mick, that have made purchases in 4 quarters out of the quarters that I have picked, which is all of them. So now I have that little piece of information displayed on color, which is great. I could already use it like this. I actually don't need to visualize these anymore, the counts. That was just a way for me to get an understanding of what was going on behind the scenes. Now we have that information on color. There's no reason why I couldn't just take this to filters, make it true. That condition needs to be true. Number of quarters selected equals the number of quarters selected that the customer has made a purchase in. And now I have that list. I have changed the way a fundamental element in Tableau, which is just a dimension filter, works. So now when I add elements, Q4 2013, I'm not adding the customers that purchased in 2013 Q4. I am removing the customers that have not purchased in all of the quarters that I've selected. And my list gets smaller and smaller and smaller as I keep selecting quarters. All right? Cool. All right, so our very last example, I would call it a bonus example. It's again something that we can do on maps, and it's again to give you an idea of how this technique, this one single technique, going back to the understanding of the order of operations, can be applied to so many different things. We've used it for retention, we've used it for cosmetics in a chart, breaking down a line only when it makes sense to break that line. And in this one, we're using that to, again, make a chart look very, very pretty, but also change the default behavior of the product. Now, this is a use case that everybody loves, in my experience, and it's something that Tableau still sort of struggles with, which is drilling down in maps based on a selection of a user without having a bunch of maps scattered in your dashboard. So the way this one works is I have the United States here, as you all know. My geography is pretty bad. Where are we? Louisiana, there it is. When I drill down on Louisiana, keep only, boom. I'm changing the level of detail of this aggregation, of this visualization, and I'm bringing that down to the city level within the same chart. So changing sort of the default behavior of Tableau, where I would need to pass that as an action filter to a different chart. And then here I have a way to just go back to my all, and then I can do that again for, I don't know, Washington, which is where our Tableau offices are located. Okay? So how do I achieve something like that? So here I have the two maps. They're actually two different maps, but they're in the same sheet. So I have duplicated my latitude. I have the ability to visualize two maps and bring two separate levels of details to the view. This one is broken down by state. So the first metric, the first latitude, is broken down by state. The other one that drives the map below is broken down by city as well. Okay, so it goes down to that level. Now I have a calculation here they will probably recognize by now. I'm using that technique again. I want this visualization to behave in a certain way if no states have been selected at all. If nothing has been selected, I want you to show the states. If a selection has been made, which means the count distinct of state fixed is now well, in this case, no selection has been made, the count distinct will be bigger or equal than the drill down threshold, which I have set to be 49, which, if I'm not mistaken, is the number of states in the continental US. If that's true, that means no selection has been made at all, because I have all of the states that I have in the data set visualized. In that case, I want you to visualize that state. And this will replace my standard state here. Now, the other one will be exactly the opposite. I have a show or hide city calculation that does the opposite. If the count distinct, again, fixed, is smaller than the drill down threshold, which is 49, it means a state has been selected. It means the user has triggered a drill down action, and I want you to display the city instead. Hit OK. Let's replace this state, and this one I need the standard state and the show or hide city. And now, when I go back again to Louisiana, keep only, doesn't work. Why? Yes, context. We haven't added that to context. So the fixed calculation ignores the filter that we made, so it still thinks that there are 49 states selected, which is not true because I have selected only one. But then, when I do this, I add this to context, and as if by magic, the calculation now works. The count distinct is displaying the correct number of states that have been selected, which is 1, and the two calculations, the one on state and the one on city, now work as designed, and they show me exactly what I want to see, which is only the city selected. And now, easiest trick in the Tableau analyst book, dual axis, and now I have those two maps overlaid, one on top of the other, and this filter is an inclusion filter. It can be visualized just as any other filter. bring it back to all, California, drill down, and my little LOD magic, paired with my knowledge of how the order operations work, has made this possible, has changed the way that Tableau behaves, has allowed me to unlock a different filtering scenario for my map. Now, I promise you that I will only show you one single slide. That was a very small lie, let's say half a lie. I'm going to show you a second slide, but it's the same slide. If you haven't, I probably repeated that a few times, but I'm going to repeat it another time. The key to everything that we've done today, to use LODs in a slightly different way to what you use them for. Let's go back to the first example. We saw an example on how to use LODs in a very powerful but very traditional way, where we're using them to aggregate at a deeper level than what we have in the view. Now we're using them for something entirely different. And everything that we've done is based on this, the knowledge of when things happen in the pipeline of execution of things in Tableau, calculations and filters. All right, I'm going to remind you once again that this is tightly related, in my opinion, analytically, to the release of this new functionality, set actions, which I really recommend that you check out in these sessions. And most important slide of them all is please rate the session. It's really important for us to know if you like the session, and it's really important for us, even more important, to know how to make it better. So please go on your app. It only takes 5 minutes, probably less, a minute. So do rate the session. And now I believe we have a little bit of time for Q&A. Thank you very much for coming. Thank you.